So next up, want to talk a little bit about open pipelines. This is something that Autodesk considers very important. We've done a lot of work in the past supporting open standards for the pipelines in our industry. Everything from, as Chris mentioned, FBX, Alembic, OpenEXR. We've contributed to all of these things. And a few years ago, Pixar reached out to us and said that they were looking to take one of their technologies to a much more open world, into open source, and to make it available to everyone. And Autodesk as a group jumped on the chance because we saw a chance also to overhaul a lot of the stuff that we were doing around modeling surfaces, everything else. So it was a big chance for us as well. And we also saw the benefit of allowing the industry as a whole to be able to use this one technology that could be kind of taken advantage of in graphics cards and everywhere you could possibly do it. So at this point, I'd like to welcome up Bill Polson, Director of Industry Strategy at Pixar, to tell us a little bit more about that.
Hi, everybody. Thanks for having me at the user group. This is awesome. Hope you're having a great SIGGRAPH. Let's get a... Don't start my clock until you start my videos, right? 5 minutes. There we go. No, one more. We can start here, that's fine. Or we can start here. Welcome. Next slide. So what the heck is a subdivision surface anyway? Well, look, it's Buzz, it's Woody, it's Maya, it's Mater, it's McQueen, it's every model you've ever seen in a Pixar film since A Bug's Life. It's 50,000 models and 14 feature films. It's 15 years of work on this technology. We build our models, all our models in Maya. And so why do we like subdivision surfaces? They are lightweight. Woody is 30,000 faces. They support arbitrary topology. So here's Mum Bear up close. We put the edge loops where we need them to carry the features and the animation flow. That's it. We don't worry about anything else. We don't worry about topology. OK, they have powerful edge control. Here's McQueen's wheel in its polycage form, fully subdivided. Let's get a little bit closer in a render. Let's get really close. What I want you to understand is every edge you see is a single edge loop. They have varying curvatures because we annotate the edge with the sharpness we want. We don't duplicate and triple up and so forth the edges to carry the curvature. We simply annotate it with the sharpness we want. That makes the models incredibly light. They're easy to texture. Here's a model with 1,300 faces. Here's a PTEX file. One texture per face, and you're done. There's software to support that. PTEX is an open source project from Disney. You should look it up. Subdivision supports hierarchical editing. This is a snowfield, a single low-res subdivision model. The horse runs through it, generates hierarchical edits to that. This is not a displacement map. This is actually moving the geometry during the rendering phase. Okay? So that's why we like subdivision surfaces. Why do we make them available to everybody? Well, we saw that a few years ago that GPUs were going to be powerful enough to render these things. And we thought a standard will emerge on these things. We better get ahead of it. So we decided to get all our code up there on GitHub. You can get it. You pull it down. You'll get all kinds of backends for different GPUs. You get all kinds of rendering algorithms. They all hit the same limit surface. That's our role in this, is to make sure the surface stays the same. OK. Just a note about subdivs in Maya. People say, wait a second, Maya already has subdivs. Yes, it does. It has a wonderful subdivision implementation. It's great. It's fully compliant and accurate with RenderMan and implements all the advanced Kaplan-Clark features. We've been working with Maya since 2005 on this. But it's CPU-based. To put subdivision onto a GPU takes some new algorithms. We developed those algorithms. We put them into OpenSubdiv. And we want to get them into Maya now. Okay? So we are working with the Maya development team. We have one guy on site full-time. He's in the pod with our R&D crew. He shares an office with one of our Subdiv team. And he's doing the heavy lifting of getting OpenSubdiv into Maya. It'll always be on. No need for preview mode. You know what I'm talking about. OK, sneak peek. Let's go. Here's Mike from Monsters. He's in Maya. We build him in Maya. We have a real simple rig just so you can see some things. Here's the base mesh. Again, he's a light model, 10,000 faces. At the base level 0 mesh, you get a lot of faceting. So let's turn on Catmull Clark. We're still in Maya. It's going to take us a while for Maya to figure this out. Level 2 subdivision, he looks pretty good, but if you zoom up close, you'll still see the faceting. We have now gone down from 45 frames per second to 15 frames per second. We're still just in Maya. There is no OpenSubdiv just yet. Okay, now we're going to turn on OpenSubdiv. 60 frames per second, we're subdividing to level whatever we need to make it look good. We zoom in and out, we'll go to level 6, we'll have a few million polys on the screen. They get so dense that it looks like a limit surface. It's just a cage subdivided that fast. And yeah, when you get that close and you turn the subdiv up that high, it'll slow down a bit. But we are at 60 frames a second for this level of quality, which is smooth at basically any camera angle. And here's the thing I want everyone to understand, the thing I keep harping on over and over and over again. When you turn on OpenSubdiv and you're drawing it this way, the only thing Maya knows about is the 10,000 faces of Mike, period. The 6 million faces that are being drawn on the GPU knows about. That's it. We keep the low poly count on the CPU. We keep the high poly count on the GPU. OK. And we're almost done with this. I have 12 seconds left. This is coming as soon as we can get it done. Thank you.